Welcome to today's explainer. Look, if you work with financial data, or honestly, any kind of complex business reporting, you absolutely know the dread of feeling like a data janitor. You know what I mean? Spending hours doing tedious, manual spreadsheet work, endlessly chasing transactions, and worrying that just one wrong click is going to completely break a mission-critical report and ruin your weekend. Well, today, we're going to explore a really fascinating concept developed in the Seattle method that completely reimagines how we handle data: the digital information organism. Okay, let's dive right into this and see how we can finally digitize the chaos. Here is exactly how we're going to break this all down today. First, we'll look at the spreadsheet problem. Then we'll move into a structural advantage, check out the atomic building blocks, peek inside the molecules, and finally wrap it all up with the future of reporting. Basically, we're moving systematically from the big macro headaches of everyday reporting right down into the microscopic architecture that actually solves it. All right, section 1, the spreadsheet problem. It's time to digitize the chaos. We've all experienced the deep frustration that comes from dealing with fragile electronic spreadsheets. They're the backbone of so many mission-critical processes, yet they are just incredibly easy to break. I love this quote because it hits the nail right on the head. The human bucket brigade. Think about that for a second. Think about how much time we waste on this incredibly fragile, not to mention costly, practice of manually moving text from one document to another. Just copy-paste, copy-paste. It's literally the exact opposite of a reliable automated system. So why are we stuck in this loop? Well, the root cause of our spreadsheet misery really boils down to two concepts: complecting versus composing. Now, when we complect information, which is just a fancy way of saying we intertwine and tangle it all up, it becomes wildly complex and therefore super fragile. But the fix? The fix is composing. When you compose data, you assemble independent pieces into a coherent whole. Composing makes things simple, and as we all know, simplicity is an absolute prerequisite if you want reliability. Which brings us to section 2, a structural advantage. Let's talk about separating the info. To move from tangled spreadsheets to reliable systems, the Seattle method proposes a massive shift in how we view reports. We have to separate the information itself from the costume it wears. You see, the document itself, like that PDF or Excel file you're staring at, is really just a costume. And if we strip that costume away, we're left with the raw data. Which leads us to a pretty massive question. How do you turn digital information into a Lego-like artifact that's actually reliable? Because let's be real, Legos are amazing. They're modular, they're standardized, they're portable and reusable. We want our data to behave exactly like Legos. To get that Lego-like precision, we're moving into section 3, the atomic building blocks. This is all about managing complexity. We can use the atomic design methodology to handle this, and it relies on a metaphor I absolutely love: building a house. Let's walk step by step up this information hierarchy. Step 1, you've got atoms. These are your raw materials, like 2x4s and bricks. Step 2 brings us to molecules, which are the functional units built from those atoms. Think walls, doors, and windows. Step 3 is organisms. These are the working subsystems, basically the completed house itself. And finally, step 4 introduces species, representing categories of organisms. So imagine a whole neighborhood made up of different types of physical structures: a warehouse over here, a skyscraper there, maybe a residential home. Okay, let's zoom in on the very foundation, the atom. Atoms are the absolute lowest level of stuff we work with. In the digital world, we're talking about the technical syntaxes used to physically define our logical ideas. Stuff like XBRL, CSV files, or RDF. They're the physical code, the cement and the rebar, if you will, that actually instantiates our data. Now, before we get too deep into the individual pieces, let's jump ahead for just a second to define our end goal, the organism. An organism, or what we might call an information block, is the fully assembled subsystem. It's the completed house. It's structurally sound, and it conveys a common shared cognitive understanding. But to build this sturdy house, we really have to understand the smaller structural pieces holding it together. So let's dive into section 4, inside the molecules, and look closely at these functional units. We're shifting our focus to the walls, the doors, the roof of our data house, to see how accounting logic is actually built and held together by logical bonds. There are 4 specific types of molecules we need to know. First up is the element molecule. Elements are the core concepts we're dealing with. They can be primitive, meaning they can't be broken down any further, or they can be compound. Basically, elements set the stage for everything else we're going to build, defining the exact notions our information organism will use. Next, we have the connection molecule. Now, if elements are the ideas, connections are the glue that brings those isolated ideas together into a meaningful structure. They describe exactly how these elements are allowed to relate and associate with one another. Then we hit what might be the most crucial piece, the condition molecule. Conditions act as the critical quality control layer in our data house. They're the rules, assertions, and restrictions that absolutely must always be satisfied. This actually borrows from lean manufacturing principles, specifically something called polka yoke or mistake proofing. Condition molecules are literally what make our digital reports mistake-proof. And finally, we have the fact molecule. Facts are the actual, tangible data points we're reporting on. They're the specific measurements or observations, usually expressed with numbers and words, and they're built on global open industry standards. All right, let's see how this all comes together in the everyday reality of a financial professional. Take a look at this. Your element might be the primitive idea of assets, or maybe the compound idea of a balance sheet. Your connection links them up by stating assets is part of the balance sheet. Then, your condition enforces the unbreakable rule. Assets equals liabilities plus equity. And your fact? That provides the tangible observation. Microsoft assets as of June 20, 2017 was $241 billion. By assembling these molecules, you construct a flawless functional unit of logic. Which brings us perfectly to our final section, the future of reporting and the rise of model-driven systems. We've seen the microscopic building blocks, so let's zoom back out to the macro vision of industrialized, automated reporting. A really vital concept to grasp here is the holon. A holon is something that is simultaneously a whole, but also a part of a larger whole. A single fact is a holon, a structure made of facts and conditions is a holon, an entire report is a holon. Because this system is so incredibly modular, treating data as holons allows everything to connect seamlessly in context. The details in one digital information organism can reliably connect to a summary in another. It's brilliant. And this right here is the ultimate goal, model-driven reporting. We are moving completely away from chaotic document copying. Instead, we're creating a single, stable semantic structure, a graph, that represents one true version of the information. This graph is designed first to be easily interpretable by a machine, which unlocks massive industrial automation. But, and this is key, it can also be instantly projected into a rendering that humans can easily read and understand. No more costumes hiding the truth. I want to wrap up this explainer with a really powerful vision. When we fully embrace digital information organisms and model-driven reporting, the result is freedom from drudgery. Just imagine an industrialized future where accounting and auditing are completely digitized through open systems and mistake-proof building blocks. Your expertise is finally freed from manual data entry and endlessly chasing transactions. So I'll leave you with this question to chew on. How much more strategic, how much more impactful could your work be if you never had to be a data janitor again? Thanks so much for joining me today, and I highly encourage you to start thinking about how you can start composing rather than complecting your own digital information.